students, again we are here to discuss the chapter WF. That's the matter around surrounding. So in the last class, what did we discuss? Can we remind one more time? Okay, so in the last class we discussed about the sublimation process. Okay, so what does the sublimation process tells us? The sublimation process is nothing but it is a process in which the solid matter convert directly to the gaseous state on heating. You have to remember this point. The solid convert to the gas on heating and gas convert to the solid on cooling without passing to the state of the liquid is known as the sublimation. Better. So the sublimation process we already discussed. So what you want to take the example of the sublimation process? Simple example, the naphthalene balls you have seen, better, you have to use in your houses. The naphthalene balls, nothing but we call as a dambar goolies in the Kannada. So those naphthalene balls we used to keep in our dresses. Okay, why means to avoid of bad smellings or to avoid of the cockroaches attack on those dress items. So we used to put the naphthalene balls. So the naphthalene balls, you see that there is solid in state, right? But after some days, the width of the naphthalene ball is going to decrease. Why it's going to decrease? It is going to convert into the gaseous state, right? The solid already converted to the gaseous state, right? So the naphthalene ball satisfy the process of the sublimation, because what the state of matter tells us, a solid should convert to the liquid and the liquid should convert to the gas on heating. But here the naphthalene ball will directly convert from solid to the gaseous state, right, without passing through the state of the liquid. So I take the naphthalene ball as the best example of the sublimation process, right? So today we are going to discuss about the next topic called as the effect of change of pressure. Right? So what does the pressure affects? Right? So what does and how does the state of the matter is going to change its state on applying the pressure or on changing the pressure? Just understand by this figure. So in this figure we taken the gas, liquid and it's a solid. Pardon me, it's a solid. So we taken gas, liquid and solid states. So this is a compressor. The piston is a compressor. This is a compressor. The molecules of the gaseous state, they are away, very much away from each other. Distance is very much. The molecular space is very much. So when the gaseous state or the gas is compressed in a piston, what will happen? Whenever you are going to compress the gas, what will happen? Actually, the distance between the molecule will decrease. What the distance between the molecules of the gas? It's very much. So the distance between the molecule is going to decrease whenever we compress the gas, and it will satisfy the molecular gap of the liquid, and as a result, the gas will convert to the liquid because the molecule space is decreases to the state of the liquid. So the gas can be compressed and converted to the liquid state by applying the pressure. So that again the gaseous state molecule is again compressed in a compressor. So what will happen? This gap between the molecules again decreases. The gap between the molecules of the liquid state is again going to decrease, and as a result, those molecules will come closer to the state of the solid, and as a result, the liquid will convert to the gaseous state. Means when we apply the pressure to the gas, it will convert to the liquid state, and when we apply pressure to the liquid state molecule, it will convert to the gaseous state. So that is the effect of pressure. We can say that effect of change of pressure. We are not decreasing here the temperature, or we are not decreasing here the temperature. We are not increasing or decreasing the temperature. We are only changing the pressure. Right? When we are changing the pressure, or when we are applying the pressure, we see that the gas molecule convert into the liquid, and the liquid is converted to the solid state. So this is nothing but the effect of change of the pressure. What the effect of change of pressure tells us that if we compress the gas in the cylinder, right? It's the cylinder. If you compress the gas in a cylinder, the distance between the molecules, right? The distance between the particles of the gas is reduced, and finally gas is liquefied. This process is called as a liquefaction or liquefied. The gas is liquefied whenever we are going to apply the pressure to the gaseous state. In which? In a cylinder. In a cylinder. So, with the help of a cylinder, if you are compressing the gaseous state molecules, it is going to convert to the liquid state. So, that the reason it is called as a liquefied. This process is called as liquefied. Nothing but you are going to use some of the compressed gases in your household device also. Like example, that which is our LPG. What do you mean by LPG? LPG nothing but it is liquid petroleum gas or the liquefied petroleum gas, right? So what we are doing to the LPG? Simple, we are compressing the gas in a cylinder. How the LPG is there? Our LPG is a cylinder, right? In that cylinder, we are inserting the gas, which is a natural gas we are going to use. In that gas, what we are doing later, we are compressing that gas. If the pressure is built that much, the molecules of the liquid is going to attain their molecular gap between the liquid molecules. As a result, the gas is converted to the liquid state. So as a result, what we say that our household LPG gas is called as the liquefied petroleum gas because we have compressed this gas and converted to the liquid state. So the reason is called as a LPG. One more is there which is going to use for domestic purposes like now vehicles. Which gas we are going to use? CNG. Most of the vehicles nowadays they are going to use the CNG. What is meant by CNG? CNG nothing but compressed natural gas. That is the CNG. Right. Again, the meaning is here compressed natural gas means the natural gas is compressed and as a result it is liquefied. So you may have heard about the oxygen. What the oxygen is used in the hospital? They are going to fill in the cylinder, right? But whether the cylinder filled oxygen is a gas oxygen or a liquefied oxygen, we have to just consider. We are filling the gas in a cylinder by applying the pressure. As a result, the gaseous state molecules they are converted to the liquid state. So this is all an example of the effect of pressure. We can say that we are going to use different fields. Like we are using the effect of pressure in our LPGs. We are using this effect of pressure in the vehicles for running the vehicle as a source of energy. We are using the CNG gases, and also we are using in the hospitals also, that is nothing but the oxygen cylinders. So why the patients are going to provide the oxygen cylinder? Why this oxygen is not satisfied? So we are compressing the natural gas, that's the oxygen in that cylinder, and as a result that gas will convert it to the liquid state. And when we are taking that gas outside, again the liquid will convert to the gaseous state. The liquid will not come outside. Why? Because the pressure in the container is more, and as a result the gas is in liquid state, but the pressure in the environment is lesser. So when that molecules of the liquefied molecules will come out of the cylinder, again they will convert it to the gaseous state, right? Will not convert it to the liquid state because there is a pressure in the cylinder. There was a pressure, due to the pressure that maintained to be the liquid. But when that liquid is coming outside, again the pressure in the surrounding is less. That liquid again will convert it to the gaseous state due to the lack of the pressure. So we can say that that is the effect of pressure we are going to see in our day-to-day life. The next topic to discuss, that is the evaporation, right? So you are very familiar with this process of evaporation. What do you mean by evaporation? Evaporation evaporation is nothing but it is a process in which the liquid changes into the vapors at any temperature below its boiling point. So that process is called as the evaporation, and this evaporation is a surface phenomenon. Simple. To understand the evaporation, we have to just remind one more time what do you mean by boiling point. What is boiling point? It is a point at which liquid becomes a gas. That point is called, or the temperature is called as the boiling point. But here we are discussing about the liquid changes into vapors at any temperature. We are not talking about the temperature at which the liquid is going to boil. At any temperature below its boiling point. Means below the boiling point, the liquid will not convert to the gaseous state. That is the state we discussed already. But evaporation tells us that below the boiling point at any temperature, what happens? The liquid converting into the gaseous state. So so that process we are going to call as the evaporation. Then we will ask the question, sir, how it is possible without reaching to the boiling state of a liquid, how the liquid will convert to the gaseous state? That may be your question in the mind. So how means simple way we can discuss by the factors affecting the evaporation. Simple. Take the first factor is exposed surface area. There are 4 to 5 factors are there. We will discuss one by one. The first factor is exposed surface area. So we are going to take one activity, or we are going to conduct one activity. I will tell you the activity. Just do your own. Take one glass. If you want to understand the process of evaporation, so kindly do this experiment in your house. Take one glass and fill half of the glass with the water. That is the first procedure. And label the glass. Means how much is the level of the water is there, and up to that you just label the glass. With the glass filled with the water. And take one more container which area is more. Like just take the plate. You already have the plates in your home. So take the plate and again the plate also fill with the water. Again you fill the plate also with the water. Now again mark how much is water is there. Mark the level of the water in the both containers. One is a glass container, another is a plate container. So after keep the both in airy place, like in your just in a hall, you just keep this both containers by untouched. You should not touch the both containers for some time, or maybe one day, or maybe for some hours. You don't touch them. Just leave it for some hours in your room, right? In the open area, you just leave it for some hours or one day. Just so after that, you notice that the percentage of the water in the glass and in the plate. What will happen? Just note down the percentage of the water in the plate. The evaporation of the water in the plate will be more compared to the evaporation of the water in the glass. In the both the container, you will notice that the percentage of the water is decreasing. First thing, we notice in the both conditions that the percentage of the water will decrease in the glass as well as in the plate. That is the first condition. But the percentage of the decreasing is nothing but if the water is decreasing without the boiling point, right? So that process will be called as the evaporation. But the evaporation process in the plate is more than compared to the glass. Means the water present in the glass will evaporate less as compared to the water present in the plate. Why it is so? It is because of surface area. If the surface area is more, then the evaporation will be more. If the surface area is less, then the evaporation will be less. Simple. So what you do, just take your, you know that how to wash the clothes. After washing, what the process you are going to use? You just squeeze the clouds, because the water droplets are present in a more quantity. After squeezing, you just increase in the area of that cloth and you will hang on the thread. Right. So do one thing, squeeze and put it as usual. Don't increase the area, you squeeze and put it as usual. And one shirt to do like that and one shirt to just increase the area. Consider after some hours which shirt is dried fastly. It shows that the shirt which is increased in area, that will dry very fast because the area is more. Why the shirt is squeezed and kept like that only is not dried? Because of the area is less. If the area is more, then what will happen? The process of evaporation will be more. The drying of the clothes, the washed clothes, is also the process of evaporation only. Why? What is the boiling point of water? The boiling point of water is 100 degrees Celsius. Right? At the 100 degrees Celsius only, the water will becomes a gaseous state. But we see that our environment will not reach the 100 degrees Celsius. If the 100 degrees Celsius means we all will boil here, right? So it is not that much temperature. Only hardly maybe 30 to 38 degrees Celsius will be there, right? In our side, in the Bidar side area. So in the 30 to 38%, the degree of Celsius only, how the water is converted to the gaseous state? That process only we are going to call as the operation. Because below the boiling point, what is the boiling point of water? If you are taking the water as example, the boiling point of water is the 100 degrees Celsius. Below the boiling point, the water is becoming the gaseous state. So that process we are calling as the process of evaporation. Simple. The rate of evaporation increases on increasing the surface area. Right? The rate of evaporation is here more compared to this, because the surface area of the glass is less compared to the surface area of the plate. Means if the area is more, then the rate of evaporation will be more. Just do one more example. Take the kerchief. Right? If you are hurry to go outside, but the mom just washed the kerchief right now. So you want to take that kerchief. What are you going to do? You just take the kerchief and you will keep on the bike by increasing the area. So what will happen means we see that the kerchief will be dried very less time. So now the second factor affecting the operation is the temperature. This is the first factor. The first factor is increased surface area. The second is the temperature. Then how does the temperature is affecting the process of evaporation? Simple. The rate of evaporation increases with the increase in the temperature. Right? The evaporation will be more when the temperature of the environment will be more. Right? In the summer season, how does the clothes will be dry, and in the winter season, how does the clothes will be dry? You just consider that example only. That will be the best for you. Right? So now this season, what we are saying right now, what we are seeing right now, this season is winter. Right? So in this season, we see that due to the lack of the sunlight. So what will happen means, if you take means due to the lack of the sunlight, our clothes will not be dry. So as a result, what we are going to do? We are going to wait for drying of the clothes. So, but in a summer season, if you keep the clothes only for 1 hour or 2 hours only, your clothes will be completely dry. This is because of the process of evaporation will be more when the temperature of the environment will be more. Means even the temperature influences the process of evaporation. So right, now we'll discuss the third. Third is, students, that is the humidity. The third factor affecting the operation is the humidity. What is the humidity? Humidity is nothing but, just write down in a separate manner what the humidity means. Humidity is nothing but, it is the percentage of water droplets present in the atmosphere is called the humidity. Right? The humidity in the summer and the humidity in the winter, it will be varies due to the temperature, because in the summer season the humidity will not be that much, because what are the water droplets are present in the atmosphere that all are going to vaporize due to the heating effect, that is sunlight. But in a winter season, what will happen means due to the lack of the sunlight, the water droplets will remain or suspended in the air only. So as a result, the humidity of our environment or our atmosphere will be more. So what does the humidity will influence or affects the rate of evaporation? If the humidity is more, then the evaporation will be less. Understand? If the humidity is more, then the evaporation will be less. If the humidity is more, then the evaporation will be less. If the humidity is less, then the evaporation will be more. Simple. If the water droplets are already present in the atmosphere, that is the humidity. If the humidity is more, means water droplet percent is more in the atmosphere. So as a result, the process of evaporation will be less. So that's the reason we are saying decrease in humidity will increase the rate of evaporation. Right. Decrease in humidity will increase the rate of evaporation. The rate is nothing but the speed of evaporation. The speed of evaporation will be more when the humidity will be less. Decrease in humidity will increase the rate of evaporation. So that's the third factor we are discussing about the evaporation. Now the fourth factor. Fourth factor is the wind. Then how does the wind affect the rate of evaporation? Simple. Increase in the wind speed will increase the rate of evaporation. How? If the wind speed is more, then the rate of evaporation will be more. I see the example. Take the kerchief. Right? If you are on the bike, put it on the bike. So when you are going to be going on the bike, what will happen means the wind speed will be more. As a result, your kerchief will be dried very fast. Then compared to the kerchief you put it on the road. Right? So that's the reason we say that increase in the wind speed again will increase the rate of evaporation. If you want to understand this one more time, means take that same experiment or same activity. Take a glass, take a plate, one more time, and again mark the level of the water in the both. So in the first case, increase in the area we kept in a open room or we said in a hall. So in this also we will keep in a hall only, right? So but you have to just do one more thing here, just on the fan. Put on the fan. What will happen? The fan nothing but it will give the more amount of wind. The speed of wind will be more. As a result, again conduct the same experiment with on the fan. Put the both containers below the fan where the wind will flow more, and after some hours you just check that the both containers below the fan and the both containers without the fan. When we on the fan, what will happen? When we off the fan, what will happen? So we will notice that the process of operation will be more when we are putting this both container below the fan. Simple case is that the wind also influence the rate of the evaporation. Right? So if the wind speed is more, we say that or we study that the process of evaporation will be more. So there are the four factors are there which are influencing or affecting the rate of evaporation. The first one is the first one? The first one is increased surface area. Second is temperature. Third is humidity, right? The third is humidity and the fourth is the wind. So these are the four factors which are affecting the rate of evaporation. Now, evaporation causes the cooling, right? How the evaporation causes the cooling? The particles of the liquid absorb the energy from the surrounding to regain the energy lost during the evaporation. So the absorption of energy makes our surrounding as the cooling. So this absorption of energy, we say makes our surrounding as a cool. How? Just take one liquid. So you will not have this liquid in your home, but I will suggest you to come to the chemistry lab. The liquid name is acetone. Right? It is a liquid. So the acetone is a liquid, right? It will available in the labs, the chemistry labs. So take this acetone liquid, put it on the hand. So you will observe that after putting the acetone in the hand, you will observe that your hand will totally become cold. Why? So like, or if you don't have the acetone answer, don't do this one. I will tell you. That's the petrol. Right? So petrol will also give the same effect. When you put the petrol on your hand, you will feel that your hand will becomes cold. Why? Because of the evaporation causes the cooling. Simple case, what happens means, what does temperature we have in our palm? So just imagine, I am pouring the petrol in my hand, right? On which area does the petrol will fell? Already I have the energy, right? Already the heat is present in my palm. So after adding of the liquid on my hand, that may be the acetone liquid or that may be the petrol, what happens means they will take the heat from my body or the heat from where the area where they are placing. So as a result, why they will take the heat? Because they lost the heat, and as a result, when they are going to come into the environment, they are going to take the environment heat to regain the heat what they lost. Right? So actually they lost the heat. When they are going to place it on my skin, the lost heat they are going to try to again regain that heat. So when the heat is present on my hand, when they are placed on my hand, what happens is they will suck the heat from my hands. As a result, my hand will, the area where that felt feels to be the cold. So that's one of the process there, that is called as the process of evaporation, also causes the cooling effect. I will not suggest you to add the petrol on the hand because that is dangerous for your body. Okay. So it shows us that simple thing. It shows that even the evaporation causes the cooling effect. Simple. When you place the petrol on the hand, you will feel that after some minutes only, the petrol will not be in your hand. Right? It will be evaporate very easily. So I will tell you one more example. Simple. We are already very familiar with this one. Are you using a sanitizer? Right? We are using a sanitizer. When you put the sanitizer on your hand, what will happen? You are going to feel cold. And after 1 minute only, all the liquid molecules will be vaporized. You will not feel any liquid molecules. Right? Why it is so? When you put the sanitizer on the hand and when you rub, the area where the sanitizer will be there, that all area will become cold. Why? Because of they will absorb the energy from our hand and our hand energy will be gone there. As a result, our hand will feel cold for some extent. So the reason we say that the operation also causes the cooling. The best example in nowadays situation is the sanitizer. The sanitizer is again contain the alcohol particles. So we see that even the operation causes the cooling effect. Then my one more question is that how many states of matter are there? Right? Simple. There are 3 states of matter are there, which are solid, liquid, and gas. These are the 3 states of matter. But after this all things, the scientists were talking about the 5 states of matter. Actually, what we have 3 states of matter. But afterwards, the scientists were talking about the 5 states of matter. Then which are the 2 states of matter again? The 4th state of the matter is the plasma, and the 5th state of the matter is Bose-Einstein. So these are the 5 states of the matter: solid, liquid, gas, plasma, Bose-Einstein condensation. We say that the Bose-Einstein condensation. So these are the 5 states of condensation, you can say, or condensate. Both will be Bose-Einstein condensate. So we have the three states of matter only, but afterwards later the scientists were talking about the five states of matter. There is nothing but solid, liquid, gas, plasma, and Bose-Einstein condensate. So these are the five states of matter. Laterwards the scientists were discussing, that was not mentioned in our syllabus. Just they are talking about the five states of matter. Already the plasma is in some of the syllabuses. Already it's already maybe studied about in the 8th standard. But also there is one more stage that is called the Bose-Einstein condensate. Right. Some measurable quantities are there and the limits are there. Just remind for one more time. I am just mentioning some of the measurable quantities in our day-to-day life. Okay. So quantities, unit, and the symbol. I made the three columns there. So the first quantity is the temperature. In which unit does the temperature is measured? Temperature is measured in the Kelvin unit, and the symbol is the K. That the K is the Kelvin. And the length is measured in the meter, symbol is the m. Mass is measured in kilogram, right? Mass is also always measured in the kilogram, symbol is kg. Weight is measured in the Newton, and it's always written by the N. Volume is measured in the cubic meters, right? Volume is measured in the cubic meters, so denoted by the symbol m3, right? That's nothing but meter cube. Then the density is measured in the kilogram per meter cube, right? Nothing but kg per meter cube. Symbol is there, kilogram per meter cube. That is the unit and the symbol of the density. Pressure is measured in the Pascal. Pressure is measured in Pascal. Symbol is PA. What is Pascal? Pascal is nothing but the name of the scientist. Pascal is the name of a scientist who discovered the pressure. As a result, the unit of the pressure becomes the Pascal, and the symbol is the PA. So, students, this is the end of your first chapter known as material surrounding. I hope that you learned the many new things and many things, and I hope that you always or you all are understood this chapter. Hope will come with the next video in the next chapter. So stay home, stay tuned.